Good day, folks. Welcome to Prize Mind Academy, where we bring brilliance to every lesson. Now, in this question, we're going to be looking at analyzing the sketches that we are given. Unfortunately, there is no free marks of sketching because it's the easiest, but now we need to know how to also interpret our graph. So let's look at that. We have given the function of f of x, it is equal to a cos b theta, and g of x, it is equal to c tan theta, okay? Or x is an element of that, blah, 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 blah. So they tell you that, okay, remember it is your what? It is your amplitude, okay? And then B, it is your what? Remember, it is in front of this. This is almost the same as X. I'm not sure why they said theta here. I don't know. Yeah, just change that to X, guys. Because if they wanted to say theta here, they should have been G of theta. So just change that to X, change that to X. Okay, so what is B? B, remember, it is the period factor. And then what is C? C is also amplitude, guys. We know that. And then, yeah. So let's look at the graph of G. Before looking at the questions, let's try to answer the questions. Okay. I'm having my graph of F here, which is the graph of cos. Where is it? Here is the graph of cos. Can you see the graph of cos starts at 3 and ends at where? At negative 3. So it tells me that my amplitude, it is what? Remember, if it is 3 and negative 3, remember the normal cos graph, it starts at here and does that, right? But in this case, it starts at 3 and ends at negative 3. So how can I find my amplitude? Remember, amplitude, it is the maximum value minus the minimum value divided by 2, which when you do mathematics, you'll get that your maximum value is 3 minus the minimum value, it is negative 3. When you divide that by 2, 6 divided by 2, it is 3. So I already have defined the value, I already found the value of A, which is 3. Okay? And then, how does it come? Okay, from here to here, it is half impulse. Remember my cos graph? It does this and does that. So here at 180, it is the turning point, and then it will complete at 360. So can you see here? It will do the very same shape, even though it starts at 3 and negative 3. If you were to draw this for until 360, it will complete its shape after what? After 360, I mean. Okay, so it means now our period, it is 360 because this, everything is the same. They did not affect the period, okay? So we'll say the value of B here, it is just 1. Why? How can you do that? You can say, okay, the original turning point, it is 180. And now the turning point that we have here, it is also 180. So 180 divided by 180, it is 1. So it tells you that your K or B, in this case, it is 1. It does not affect your graph. But let's say we had something like this. Let's say we had something like this. Turning at 90. And then let me remove this. And then ending at that part. So can you see now, in this case, my turn, can you see, okay, this is the full shape of the cos graph. So it tells you that it completes the what? The graph, right, at 180. So it tells you that there is a K, the value of K there. There is a period effect. How do I know? Because I know the normal cos graph should end at what? At 360, but this one ended at 180. So it means my K is going to be the normal 360 divided by what? By 180 here, which it is equal to what? 2 in this case. Do you see that? And I can also use the turning point and say the turning point, I know it is 180, but in this case, can you see it is what? It is 90. So 180 divided by 90 is still 2. So can you see, guys? So that's basically that. So for this one, the value of B, it is just 1. It is just a fine graph. The value of B is just 1. And then another thing, C, okay, C here, it is just the amplitude, okay? Normally, always, okay, not always, but the amplitude here, it is 1. How do you know that? You check this value here. If this value here at 45, it is 1. So 45, if it is 1, then it means the value here it is 1. But if this graph started at 2 like that, so it will tell you that the amplitude there it is 2. Okay, yes. And then we just say the value of C it is also equal to 1. And let's look at the range. What is the range of F? The range of F, it starts at -3 and ends at 3. So the range of F, the range of the graph F, it is y is an element starts at -3 and ends at 3. The range of tan has no range. Why? Because it starts at -infinity, can you see, and ends at where? At infinity. So the range, we might say, the range of G graph y is an element from -infinity to infinity, or you can say y is an element of real numbers. Okay, yes. So can I answer the questions? I think so. And can you see that at this point here, it is the point of contact. Here, it is where, at this point, it is where f of x, it is equal to g of x, also here. Also there. Okay, yes. I think we are ready, guys. Write down the range of f. How can you see the range of f? F starts from -3 2 to 3. Remember, range it is minimum to maximum. So for 2 marks, that was easy. 2 marks, -3, 2, 3. Remember, why do I include the range? Because now the graph, it is there at -3. We can find our graph. It says if m it is -45, okay, and -1 here. So it tells me that the value of x here on that line, it is 45. And then the value it is -1. I can see that. They say to me, oh, if m of this coordinate lies on G, okay, determine the value of C. Okay, the value of C, here. Remember I told you, if here it is 45 and this is 1, it tells you that it will be 1. Similarly here, if it is -45 and 1, -1, it's still the same thing, okay? What you need to take note of that is that your amplitude for tan depends on the value of that corresponds with 45. Okay, yes. So that the value that corresponds with 45, it is -1. Okay, the value that corresponds with -5, it is -1, right? But in this case, we can see that our graph the amplitude cannot be negative for the tan graph, this one, because it starts beautifully from the positive. But if it started maybe like this, and then did something like so, I don't know how it would have looked. Oh, something like this. And then this one, it is like that. Then you will have said our amplitude that corresponds with 45, it is -1. Just check the one that corresponds with 45, okay? So they want to tell you actually the divisions here, it's just 45. So yeah, the answer is just 1 there. I think we answered that. The value of C is equal to 1. Write down the value of A and B. A and B, we answered that. A, it is 3. How do we know A it is 3? It is amplitude. We found that. A, it is equal to 3. And then the value of B, it is just the period factor. But you can see that the graph, of course, it is fine. It is not affected by the value of K. So it is 1. I repeat, to find the value of A, it is just amplitude, which is the maximum value minus the minimum value divided by 2. You'll get something like 6 divided by 2, which is 3. And then when I look at this part, for determine the coordinate of Q. Ne? Determine the coordinate of Q. What is the coordinate of Q? What are the coordinates of Q? The coordinates of Q are basically the point of intersection between what? Between P and Q, right? So how do I find this? Okay, just say from 0 to this point, how much is the distance? Can you see? From 0 to that one, the distance it is 58. Okay. So it means also from that point Don't say from this point to that point. No, rather in this case, you'll start from 180. From 180 to this point here. It will also be 58 degrees, the distance. Okay. Or you can say just add another 58 units so that you get here. Can you see that? Another 58 units to get there. So basically, if this coordinate here, can you see the x coordinate, it is 58 here. So it means also from here to there, I need to minus 58. Let's see when I do that. When I minus 58, it's going to be 180 minus 58. 180, 180, I go. 180 minus 58, it gives me 122. And the value of this one here, it's going to be this one, but now in the negative direction. So it's going to be 1,1,6 instead. Okay, let's see if we did by saying, let's add another 58 on that one. I don't think it would have worked, but let's see. 58 plus from here to there, 58. I think 58 plus 58 is just 116. Yeah, so it's not 116, but it is 122. I repeat, from here, from the 0 to the point here, which is 58 degrees, it is 58. Also, when I do that again, I'm going to start from the point here, going there. Why? Because if I were to use this one, it means I will need to find the space here first. Okay, can you see now the space here from here to there? It is 90 minus 50, it is 40, 32. So it means here it will also be 32, and from here to there it's just 58. So it's up to you whether you say 90 plus 32, then 90 plus 32, it will also give you 122, or you say 180 minus 58. Okay, yes. And another thing that you should remember is that when I'm having a general solution for a graph of sine or cos, if this let me see. No, let me leave it. It's fine. But yeah, that's basically that. 122 and negative 1.6. And then they say K lies on F such that Km is parallel to the y-axis. K lies on F such that Km, let me highlight this, Km lies is parallel to the y-axis. What do they mean? It means the values of x here does not change. So it means if here it is negative 45, it's going to be negative 45 for all the y values there. Okay, yes. So then what? Calculate the length of Km. That's beautiful. Length of Km, it's just the value of y here, which is 2 minus negative 1. Remember the distance. When we want the distance from the functions in paper 1, we say for the vertical distance, we say it is y top minus y bottom. For the horizontal distance, it is just x right minus x left. In this case, you are looking at the vertical distance. So it's just y top, which is 2. Okay, so the y top, okay, let me say Km, y top, it is 2 minus of the formula, then negative 1. So can you see this, that it is 3 units, like that. Okay. Or you can say, what is the distance between K and M? You can say from here to here, it is 1 and 2 and 3. Remember the distance. We are talking about Km, which is the distance, people. The distance. So, so you do not, when you do the distance, if you're doing physics, you know you want to say it is just 2 minus 1. it will give you 1, which is incorrect because the distance from here to here is not 1. So hence you have to say it is the top minus the bottom, which will be the 2 minus of the formula here, and then minus what? -1. It will give you 3. Hope that's understood. And then the last question, it says, if the system of the axis is shifted 45 units to the left and the graph remains fixed, write down the equation that is now represented by the graph of f. Okay, if the system axis is shifted 45 units to the left, if the system axis, if this axis were to be shifted 45 units to the left, the axis, this one, my system axis, were to be shifted 45 units towards the left. So it means this, instead of being 0 here, I will have another one at, instead of having the y-axis cutting at 0, it will rather be cutting at or -45 here. This will be my new y-axis. Okay, but the x, okay, the x I cannot change that. This will continue being my what? My x. And what I want you to realize is I do not have an highlighter that tries to hide. Let me do this. Let me see if white. Can I get white? Light gray. Not light gray. I want white, guys. If I were to remove this system here, if I were to remove that, I want you to take note, to just assume this is now your new y-axis. So if that is my new y-axis, can you see that my graph did not start at 0? Okay, just assume this is your, I'll say this is y prime. Initially, you want your graph to start at 3 here and do whatever that it does. Okay, start at 3 and do whatever that it does, blah, 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 blah. But in actual fact, that will not be the case. Why? Because now, this is how our graph will look. Instead of starting at 0, which is now our 0, this one, it now started where? Okay, remember I changed the axis, so it means this will be 45. This will now be my 90. This will now be my 135. And this will now be my 180. And this will now be my 195. And then this will be now my -45, -90, -135. So it's like having a new complete thing now exists now. And now the question is, what will be the equation of the f? Now, if my graph of f was supposed to start here, but now it is here, can you see? We assume now it's here. It's starting like that. So we want to say, okay, my graph shifted towards the right by how many units? By 45 units. Because now, if I use my system like this, and now my normal graph is supposed to be like this, with this y prime, it means now it is shifted towards the right. By how many units? By 45 units. Shifted towards the right by 45 units. But now remember, if it shifted towards the right by 45 units, on my graph, remember on my graph, I'll say this is y, okay. F of x, it is equal to 8 is how much? 3. Cos b, it is just 1. X, remember if it is moved, sorry. If my point, it is moved towards the right by 45 units. So it means I need to say it is minus 45 degrees. Okay? So I'm not sure how to output this, but yeah. Take it like this. If you are moving your axis towards the left like this, can you see it will seem like your graph now is shifting towards the right. When you take your axis from here and move it towards the left, it's like your graph rather it's like we are rather taking this point here, and I feel like I had I wish rather I had a schematic thing to show you. When I take this line and move it towards the left, all my points are shifting towards the right. Can you see? Instead of having this one at the origin, okay, this is my origin, this is my y. But when I take it towards here, can you see now it's like my graph now shifted towards the right? Not the line shifted towards the left, but the graph seems like it shifted towards the right. Instead of having it here, can you see now it now cuts at, okay, this will be now our new two, our new one. So instead of cutting here, can you see it's like it has changed rather to cut where at this point, which is now 45 degrees towards the right. So what you should take note of is that when the system shifts towards left, your graph moves. It does not move, but moves towards the right by whatever you need. So basically, it means now if my graph is shifted 45 units towards the left, okay, so it will be like my graph instead rather did what? If my line shifts 45 towards the left, and then it means my graph, it does not shift. The graph will remain the same, but it will act like my graph shifted 45 units towards the right. If here it was right, it will look like my graph shifted towards the left. So I want you to understand it like that. So since when it is left here, it means my graph acted like it shifted towards the right by 45 units. And we know that when we take that to an equation, graph shifting towards the right, it is graph shifting towards the right, it is x minus 45 degrees, because right, it is when p is less than 0. So it's just going to be minus 45 degrees. So yeah, that's that. Hopefully you understood, and yeah, let's meet again on the next video and also do more interpretation of these.